All right, good evening. My name is Alicia Guerra. Today I'm going to be giving a talk called Java for Trading and Financial Engineering. So I want to thank everyone for coming out. I want to thank the San Diego Java Users Group for having me. I want to thank Seva Solutions for bringing all the pizza and delicious goodies, and thank ResMed for having us. So before I really start to get into this, I want to take the time to introduce myself. We got plenty of time, so it's all good. As I mentioned, my name is Alicia. I'm 25 years old. I'm a San Diego native. I'm a software developer based here in San Diego. So I went to UCSD for math and computer science. And I started out working as a software engineer, doing full stack web and mobile development for large corporations. And now I'm working as an independent contractor, working for mid-sized and early stage startups as a full stack developer in all different industries, in the automotive industry, finance, healthcare, insurance, diet, fitness, and tourism. I've held CTO and lead developer roles with startups based here in San Diego, as well as startups based up in LA. So some of you might recognize me. I attend this meetup group pretty regularly. I actually won a trip to San Francisco through this group, believe it or not. So I entered a raffle a while ago, wasn't really expecting anything out of it, but I won a bronze pass to the O'Reilly Software Architecture Conference up in San Francisco. So if you're new, you gotta stick around because you don't know what you're gonna get. Yeah, so this is a great group. Paul's a great guy. So I'm also active in other tech meetups. I'm really plugged into the local tech and startup communities. I've given talks at San Diego.js, at the React meetup. Well, as some of you might have heard, they recently combined, because I do a lot of front-end stuff. I've also given talks at the San Diego Python Users Group. I'm also plugged into Startup San Diego, so I'm gonna see you at San Diego Startup Week. So yeah, all right, so let's do this. So before I get into this, I would highly recommend, if you want to follow along with what I'm talking about, or if you're interested in the subject and want to get your feet wet with it, there's this awesome book called Java Methods for Financial Engineering. It's written by Philip Barker. And you don't even have to buy the book. It's available for free online. It's on GitHub, available as a PDF. All you have to do is download it. Actually, I stole a lot of my code examples that I'm going to show you later on from this book, because they're nice and short and sweet, because I can't fit 400 lines of code onto one slide. Ain't nobody got time for that. We're going to talk about high-frequency trading. So this is a Java meetup. So we're all Java developers or Java enthusiasts. I don't assume any financial knowledge. For all I know, nobody in this room has ever traded in their life and has ever worked in the finance industry. So we're kind of starting from scratch here. So if you've never heard of high-frequency trading, or HFT, it's a type of algorithmic trading. And it's characterized by really fast speeds, really fast turnover rates, and high order-to-trade ratios. It leverages really high-frequency financial data and electronic trading tools, and it has these really sophisticated algorithms and short-term investment horizons. So if you're in the trading world, you're going to hear the term low latency thrown around a lot. And if you've never heard of that, so it's when you use algorithmic trading to react to market events, and you're trying to get in there faster than your competition, to get more profits out of your trades. So high-frequency trading, how profitable is it? Why should we care about it? Why should we, take time out of our day to learn about this? Can we make money off of it? Can we make real money? Hell yes, we can. This is a really profitable industry. Just to give you an idea, if you know what you're doing, you can make big money. So 31 high-frequency traders earned over $29 million in profits in 1 month this year. So in December 2017, a bond trader made $60 million in one day doing a trade. In February 2011, a trader made $200 million in 1 week doing trading. And those are just a few examples. All right, there's a lot of cases like this of people making big money in a few seconds. There are college students, they'll sit down, for 10 minutes on their computer from home on a trading platform. They'll make $300 in 10 minutes. So this is a good industry to get into. So trading platforms, I'm sure some of us might have played with them before, but if not, that's fine. So in a nutshell, what a trading platform is, it's a software where investors and traders can make trades and they can monitor accounts through these financial intermediaries. Oftentimes, not always, these platforms come with a bunch of other neat features like real-time quotes, charting tools, news feeds, premium research. And they're often offered by brokers for free or for really cheap rates. But the catch is you got to maintain a funded account a lot of the time. So you have to, not all of us have, $25,000, to throw around, into these accounts. And sometimes you have to make a specified number of trades every month. So some popular trading platforms, some of you might have heard of these. So a big one is Interactive Brokers. Also TradeStation, TDA, Ameritrade. There's a ton, but those are just a couple examples. If you've never actually seen a trading platform, this is kind of what the interface would look like. You got a lot of stuff going on here. So the title of this talk is Java for Trading and Financial Engineering. Some of us might have never heard the term financial engineering, because when you think, oh, we're in finance, it's like, is there engineering involved in finance? Yes, there is. So financial engineering, it's the use of mathematical models to solve financial problems. And we use tools and knowledge from a bunch of different academic fields like computer science, statistics, economics, applied math. And financial engineering actually played a role in the 2008 recession, believe it or not. So this has to do with MBS, mortgage-backed securities. So it's like these asset-backed securities that are secured by mortgage, and then credit default swaps. Or CDS, it's when the seller agrees that if, the debt issuer defaults, they'll pay for it, and they'll pay the interest. So, see, the problem is, when we had the subprime mortgage crisis, the number of defaults started really going up, and that triggered more credit events. So these credit default issuers, they couldn't make the payments on all these since there was all these defaults going on at exactly the same time. So all these corporate buyers that had all these credit default swaps, they were so invested in them, they're like, oh, this is worthless, I'm losing my money off of this. So when they realized that there was a loss of value, they just started reducing the value of the assets. And that just led to a bunch of corporate failures, and then we had the 2008 recession. So financial engineering, it has a huge impact on our day-to-day lives. So why should we use Java for finance as opposed to maybe other programming languages and technologies out there? This is the Java users group, so I don't have to convince you guys that Java is amazing. So market knowledge. There's a much higher concentration of Java developers out there than, say, maybe Python developers or C++ developers. Most colleges and universities teach, Java as a first language. Not all, but, that's a big thing. And also AP Computer Science. High schools, they teach Java. So it's like a really common language. Also, Java has certified partners. If you're in banking firms want people who are certified. That's just how they are. And, in other technologies and programming languages, like maybe, Node.js or PHP, there are no certifications available. But Java technologies, they have a lot of certifications available through Oracle. And it's formal, some of you probably are certified Java developers where you pay $200, you sit down, take the multiple choice test or whatever. So Java has reliable system support. So these bankers, these corporations or whatever, when something goes wrong, when their server stops working, they want to call somebody. Okay, and oftentimes they have to pay a ton of money to IBM or Oracle or Microsoft, for database servers, when you could handle that for free with MySQL or Postgres servers. Resources. So a lot of these firms, a lot of these corporations, they're already extremely invested in Java, and when you have years worth of development in Java, when you have developers and admins and partners that are invested in Java, it's kind of hard to undo all that to switch to a different technology. Lastly, memory management. So here's the thing. Okay, pointers. The problem with pointers is, they sometimes result in leaks of data to other unauthorized applications. That's a disaster. Okay, so with Java, that's not as big of an issue as, say, like C++ or whatever. Also, you got try-catch blocks in Java, so that can be used, like, say, to prevent a program from exiting, like, with an exception or whatever. So some general advantages of using Java, not just in trading, but in other industries. It's free. We all like free stuff. It's object-oriented. It supports multi-threading. It's a mature language. It's been around for a long time. It's not going anywhere. It's cross-platform, meaning that it's compiled independent of the platform and bytecode. So you can run it on anywhere that has the JVM already installed. So that's cool. So who uses Java for finance? There's too many firms to list, but these are some of the big hitters. Like the biggest, so Bank of America, Merrill Lynch, Morgan Stanley, Bloomberg, Citigroup, JP Morgan Chase, Goldman Sachs, UBS Group, Charles Schwab. There's a lot more. All right. Okay, and see, Java dominates traditional finance, as you can see, more than, C++, Python, C#, Ruby, PHP. So there's a ton of open source trading software that's available in Java. You could literally pull up your browser and do a search right now on GitHub. So these are just a few examples. Some of you might have heard of these. ActiveQuant, JQuantLib, JStock, JBookTrader, Data Visualizer, Open Java Trading System, that's a good one, Market Analysis System, Market-Cetera. So obviously there's a ton of other languages that can be used in high-frequency trading, including but not limited to C++, Python, R, and C#. So C++, the thing is, with components of high-frequency trading that are really latency sensitive, they're done in C++, because it tends to be more efficient at processing these huge volumes of data. So Python is a little bit slower than C++, but the reason people still like to use it in quant trading, it's a higher level language, and research and prototyping are done a little bit more easily. Plus, you have all these amazing tools and libraries, such as scikit-learn, matplotlib, NumPy, SciPy, Pandas, and then R is used in statistics and data analysis. I don't know if any of you guys are involved in the Machine Learning Society or whatever. So any trading algorithm that has to be, it has to be extensively tested with sample data, and that's where R comes in. So it allows for designing projects that generate trading signals and maximize strategies returns. So Java versus C++, why would we use Java over C++ for finance and trading? Well, let's think about it this way. So let's say you have a typical Java programmer and maybe a typical C++ programmer. They each have a couple of years of experience, and you give them the same amount of time and you tell them, let's make an object-oriented program. So the Java programmer's probably going to finish first, and they're going to have more time to go back and tweak the application. So I think in a situation like that, the Java app is probably going to be faster. But see, if you tune Java and C++, as far as they can go, given like unlimited time and, expertise and resources, then the C++ program is probably going to be a little bit faster. But we're living in the real world, okay? So we don't have unlimited resources. So, so I think that's why, we'd prefer to use Java. So what about Java versus Python for trading and finance? So Python has all the language features that you'd want, like in a fintech startup. So some of you might have never heard the term fintech before, so I guess some examples of that might be like, using smartphones for online banking, maybe investing, cryptocurrency. So I guess for traditional finance, that's more like Java, but for fintech, they prefer to use Python because it's scalable. It's coupled with all these ready-made libraries, like I had mentioned before, SciPy, NumPy, Pandas, and it's real easy to handle. So, look, I'm putting them side by side right here. So Python's syntax is closer to mathematical syntax when you're using it in financial algorithms. It generally tends to be more condensed, so it's nice for doing code golf and competitions and stuff like that. Okay, maybe it's not the fastest language, but it has this simple structure that allows for these lower error rates and maybe less bug handling. So there are drawbacks of using Java in finance. I think really the biggest thing is you have this lack of control over your caches, your context switches, your interrupts. So if you have a block of memory and maybe you copy it and something happens in the native memory, but you have a different delay between runs, then the copy's gonna get slower, okay? And part of that cache has been swapped out and the copy's gonna take longer. So let's kind of look at this little example here. So the problem isn't related to GC or Java itself. Neither of these really play much of a part in this, because any operation which accesses memory, it's like accessing these plain objects, it's gonna be slower, unfortunately. And these are some tests of it. So all these tests do the same thing over and over again, with different delays, between performing tests. So the test spends most of its time in the native methods, and no objects are created or discarded during these tests. This is the same test. It's with use large pages with Java 7. So in really ultra high frequency, with your core engine, you're gonna be encountering more C, assembly, and custom hardware than OOP, C++, or Java. But see, in markets where latency requirements are a little bit more lax, C++ and low GC Java can become an option for us. So in trading, we can also take advantage of, all these cool new features in Java 8. So I think next time somebody's gonna be talking about Java 9 and 10, we're on those already. I'm still figuring out Java 8, so you guys gotta bear with me here. Okay, so Java 8, what's the first thing that comes to mind when we think of the features of Java 8? Probably lambdas, okay? So lambda expressions, they make functional programming a lot easier for us. They simplify development. See, that's the kind of syntax we're looking at, short and sweet. What are some typical characteristics of lambdas? Well, we have optional type declarations, optional parentheses around our parameters, optional curly braces, optional return keywords. So here we have a little example. So lambdas, they're cool because they enable the concept of these lazy iterations. So we don't need to worry about how to slice and dice this huge data set. So this This is like a tradable interface, and you're checking for various conditions and the relevant Lambda expressions. Like, so we're checking, is this a big transaction? Is this trade canceled? Is this trade new or unknown? So these are like free-floating code expressions that can be passed around like data. That's cool. And then also another neat feature of Java 8, for those of us that are still on it, interfaces. So before Java 8, interfaces were static, but now what's changed is we can change the existing definitions and add these concrete methods to them. So we got an example here. So we got the definition of this interface called component. So it has a single abstract method called getName, and it has these two fully implemented methods here. One's called getDefaultName, the other one's called getRegin. So the concrete methods that are declared, they have to be either static or default, or else your compiler is gonna, get upset with you. So what else do we got in Java 8 that's cool? Functional interfaces. So if you have an interface that has only one abstract method, regardless of whether it's default or static or whatever, it becomes a candidate to be able to stand in for a type of Lambda expression. So here we got an iFinder interface. And it has one abstract method and one concrete default method. So as long as we define only one abstract method, we're good. We can use that interface, we can classify it as a functional interface, and it can act as a type of Lambda expression. See, there we go. We got our Lambda expression using the functional interface. So another feature of Java 8 that we can take advantage of to make our lives easier. So functions. So functions are these like recurring patterns that we can use when we're developing applications. So it provides a set of function definitions as a library. And there's a bunch. There's like predicate, consumer, supplier, readily available, right? So even specialized functions like int predicate, long predicate, double predicate, those are available. So in this next example, we have a big trade that can be rewritten using a predicate function. Check this out. Cool. Checking for big trades and cancel trades again. So Lambda functions in that little example, they've been assigned to the predicate type to check the conditionality of various criteria, like big trades or whatever. So the predicate, it's like this library function that replaces our custom-made condition checking functions. So now we're gonna dive more into the finance side of it. We're gonna talk about how we can model stock prices, okay? So we're going to talk about stochastic processes. I'm going to define that in a little bit. So there are some concepts in that, like random walks, Brownian motion, Wiener process, Iter differentials. This is stuff you're going to have to learn, if you want to work in a quantitative firm or like get into a financial engineering program. And then log normal modeling, we're going to talk about Monte Carlo simulations and how we would do that using Java. So as I had mentioned earlier, my educational background and my work background is more, software development than finance. Okay, you don't have to go to school for finance to be a developer in the finance industry. I mean, I taught myself most of this stuff, and you can too. I'm going to show you some code examples in a little bit, and we're going to take advantage of various Java packages and libraries, and these are some of the big ones. So core Java math. Okay, what goes into that floating point? We got java.lang.math, java.lang.strictMath, and then when you have your arbitrary position math, we got java.math.package. All right, so we're going to talk about each of those. All right, so java.lang.math, we have methods for performing these basic numeric operations, exponentials, logarithms, square roots, trigonometric functions, among other things. And these are all implementations of equivalent functions, and they're not defined to return the same results. Okay. With strict math, it's different, okay? Because, the definitions of some of these require that they produce the same results as these algorithms, and we get these algorithms from what's called FDML, which is the Freely Distribute Math Library. These algorithms are written in C. They're understood as executed with floating point operations, with following the rules of Java floating point arithmetic. And then we got java.math.package, so that provides classes for performing precision integer arithmetic, like with big integer, and arbitrary precision decimal arithmetic. Okay, so now we're really gonna get into the finance stuff. So to understand how to model stock prices, we need to know about stochastic processes. So stochastic processes do have applications in other industries like biological sciences and stuff. So a stochastic process is one that changes over time in an uncertain way, because there's a lot of uncertainty in stock prices. I mean, you don't know what could happen, like Brexit could happen again tomorrow. So there's discrete and continuous stochastic processes. So the difference is, with a discrete stochastic process, you have a variable, and it can only change at fixed points in time. So say maybe, I don't know, every hour or every day, every month, I don't know. And a continuous stochastic process is one where the variable can change at any point in time. So a stochastic process, it's a series of random variables over time. So a random walk, it's when a variable, it's the behavior of a variable, it depends where the next value is a function of its present value, plus a movement of random probability, kind of like what's shown in this equation here. So this is actually a modeling of a random walk. So you see kind of this up and down movement of a variable. So that can go up, let's say our probability is 0.5, and then it goes down, because if it's 1 minus probability, 1 minus 0.5, that's 0.5. So it's gonna go up and down by 0.5, right? So these up and down movements are cumulative. So if the random variable is positive, and then the next state is the current state plus the random variable, then it's going to be an upward motion. And if the random variable is negative, then it's going to be the current state, and then you're going to go in a downward motion. That's why you have this kind of up and down thing going on. So then we have Brownian motion. So this is a stochastic process, and the random variables are all independent of each other. And then a Wiener process is a type of Brownian motion where you have a mean of 0 and a standard deviation of unity. So it's expressed kind of like this, where the x of t is the Wiener process. So this is kind of, this is a Brownian motion. This is where a drift and variance for a variable following Brownian motion would kind of look that. So it has 0 drift and a unity variance of 1. So it's a symmetric random walk. Okay. So this is a little bit different. See that line in the middle? That solid line in the middle, that's the mean value. So this shows the value of a stochastic variable following a 2010 path of Brownian motion. So this is actually from that book that I mentioned in the beginning. This is an implementation of the Wiener process. It's a random process, okay? That's why we're using the random class. So these classes are all part of the core math package in Java that we can take advantage of. Okay, so what we're looking at here is an implementation of the Wiener process, but this is generalized. So it incorporates drift with time and risk, so standard deviation. So you got some methods where you have like getters and setters for your drift and standard deviation. This is the rest of it. This is the rest of the Geo-Brownian class. You have your W-val variable that's set to the drift minus the variance. So next we're going to talk about Ito differentials. I don't know how many of you have heard of Ito calculus. So basically it extends the methods of calculus to stochastic processes like Brownian motion. So the central concept here is the Ito integral. I don't know if y'all have heard of it. It's like a stochastic generalization of Riemann integers. I mean, we've all taken calculus here. We've all heard of like Riemann sums, Riemann integrals. So the Ito differential is a stochastic equation that solves this right here. So this is an instance of Brownian motion with an instantaneous drift of A and a variance of B t squared. So you have these A and B variables here that are functions of the variable x. So if you look in this like example here, you have an implementation of the Ito process, and it computes the general Wiener process where the parameters are functions of the underlying value, like in that equation I showed you. Here's the rest of it. We're using the core math package again. We're using java.lang.math. We have our getters and setters for our mean and our standard deviation. So as you can see here in our Ito value, what are we taking in? We're taking in the mean, sigma, the time delta, our base value, and then here we have our general Wiener procedure. So next we're going to talk about Monte Carlo simulations. So we've probably heard the term Monte Carlo with respect to finance. So I'm going to show you an example of a Monte Carlo class that provides methods to generate like simulated stock prices, but they're going to be based on like input parameters like your mean, your standard deviation, your initial stock price, and that allows us to visualize every single path to value options. And I don't know if any of you were there, but I gave a talk on this before at the San Diego Python users group where you use like matplotlib to actually visualize all the different paths you can take, you know, to like see the worst case scenarios. So this is kind of what it would look like in Java. So you got this class here, it's called Monte C prices. And you know, this is a simulation process that's kind of based on the Monte Carlo method. So the class provides methods to generate these simulated stock prices. And the movements are again based on input parameters, your mean, your standard deviation, your time, and your initial stock prices. Yeah, this is kind of a big class. So the class has two imported classes. So we're using the core math package again. And there are two neat classes in the core math package. There's one called Ito process and one called Gen Wiener, so the generalized Wiener process. So that makes our life easier. So we don't even have to bother, you know, doing all that like on the previous slides. So the slide right before this one, let me see if I can go back to it. So you can see we're instantiating our Monte C prices class, like our Monte C prices, and then int n. So that sets the value for the creation of the return array size. Okay. So where am I? Okay. So, and then here we have three methods. We have sum value p, sum value ln, and these provide the basic process for handling functionality. Then we have sim value and sim value p. Those provide a process based on like the discrete process model. So that means like at fixed points in time. And then the sim value ln. Yeah, there we go. It provides like a more continuous time model, so there's random processes like continuously. And so we have some convenience methods like get value sim, get value simln, get value simp. So these give access to the final value of this simulated run. And what that would look like is like a chart with a bunch of different lines to show that, like, all the different paths that it could possibly take given the random variables. So that's actually all I have. I mean, we still have an hour left, don't we? Or what time is it? Damn it. Okay, sorry about that, guys. I mean, this is 58 slides, so I probably should have talked a little more slowly. All right, well, thank you so much for having me. So I'm giving you all my contact information. If you're interested in learning more, I know this was a really dense talk. I mean, there's a lot of really hardcore mathematics that goes into financial engineering. That's why, these quantitative analysts typically have PhDs in math. So some other free learning resources that I would recommend are like Options Alpha. You can create an account on there for free. They have a bunch of like cool YouTube videos that you can check out that really break it down. Like what's a stock, what's a bond, what's an option, what's a future. Also Investopedia, some of you might have heard of it. It's kind of like Wikipedia, but for finance. So this is my email address, my LinkedIn. So I am videotaping this talk, and I'll put it up on my LinkedIn profile. I'll put up the slides, too, in case you're interested. This is my Twitter. Hit me up. If this is at all interesting to you, I'm down to have coffee or whatever, or answer any further questions. So, damn. Okay, so we got lots of time for questions. Absolutely, okay. Like I said, I got 58 slides, so we got plenty of time. Okay. It's towards the beginning, so. Okay, here we go, yeah. So, yeah, like I said, I'm gonna put the slides and the footage on my LinkedIn profile. So like I said, you don't have to buy the book. Just do a Google search and it'll come up on GitHub. It'll have the PDF. You can download it and kind of follow along. Well, we got more time for pizza, so that's... What's up?
What the equation would say, but they're not really optimized, but they don't really for large data sets, but they are.
Well, no, not really. I mean, because there are a ton of libraries where you just call an API that does everything for you, but then you won't understand like how to do it. Yeah, it's just, the book is geared towards Java developers who don't have a background in finance and who need to learn the algorithms. Like, like when you're just starting out and you're just learning how to code and you're doing like it's not going to be optimized. Like you're going to do a for loop to add everything up instead of,
That people use that are common, popular, open source packages,
Like, are we talking about open source libraries that you can use to do this stuff for you, or are we talking about trading platforms?
No, libraries.
Oh yeah, I had mentioned a ton. So let me go back to that slide that lists a bunch of them. Like I said, 58 slides, so bear with me. Yeah, so you got a bunch of options here, and there's a lot more where that came from that are just for doing stuff like this. So call an API, it'll pull up a Monte Carlo simulation for you, like a visualization, or like with Data Visualizer. I have in the past, not currently, no. Right now, I'm actually working in the insurance industry, but I did spend a lot of time doing stuff like this. What's up?
Yes, I'm just curious to know or to find out from your project that the requirements are they usually come from your clients to tell you what they like to do and you put together a prototype using all these open source libraries, or which is the other way is to have a lot of great smart idea on your head and you go to the company and present it, hey, this is what I can do for you, isn't it cool? And so I'm just curious, like your masterpiece or your project, the requirements, where are they from?
Okay. So I used to work for an options trading firm, and they have a preference more for, because it's really high frequency, low latency kind of stuff. So they have a preference for C, C++, like using the Boost libraries for mathematics. But it's also using Java. So the main thing is speed. Okay, that's the most important thing. Like you really have to take advantage of like the multi-threading, because like literally one like millisecond can make or break the difference between like making or losing millions of dollars. Okay, and when you're using a trading platform, you're not gonna remember the day you won like $25. You're gonna remember the day that you lost like millions of dollars. So one screw up like that, or maybe the internet connection goes down, the server connection goes down, that can be catastrophic for your business.
Mostly they
Holy crap.
To give you an idea.
Hello?
they want you to implement their idea.
Okay.
They don't want that amateur, non-financial guy to implement the idea.
I mean,
His question was do you come to them with your own trading ideas and then implement your software, or do they give you a project with certain parameters?
Oh, okay. In that case, I misunderstood your question. Well, like I said, my background is more computer science than finance. So typically, I'll team up with like a data scientist and a quant, and they'll give me like the algorithms and stuff for the back testing, and I'll implement it. But you have to understand all this stuff to be able to do that.
They have this question.
Yeah, no, you could like literally like open Java trading system. Like it doesn't just come with like the APIs to get like the Monte Carlo simulations or the calculation for the random variables. Like you could literally build out an entire trading system with it. Well, see, here's the thing. Like Yahoo Finance API is free. Okay, but see, a lot of these APIs because over here I'm just talking about free and open source software. But I mean, what like the APIs you call to actually get they're paid. Yeah. No, you have to do it through there. This is like this is to do the computation. Okay, did I do something to this mic? Okay. It's something lit up. Okay. What's up?
I might have missed if you already addressed this. In the past, I had claimed Java is less suitable for things like real-time processing, apps or something like this, partially because of the fact that it's garbage collector.
Right.
I don't know the full control. Are there any strategies for managing that, either in the newer versions of Java or in anything you've seen, or is it just a matter of if you handle out garbage collection and you want to run the data code, C++?
Yeah, you know, like I said, there's a trade-off, right? So, I mean, if your firm is already heavily invested in Java and you have limited resources, then yeah, Java's the way to go. But if you have extreme like latency requirements, and then you're better off using C, C++. You just got to be careful with those memory leaks with the pointers. Wait, what? Oh, we were talking about the raffle. Yeah, you don't know what you're gonna get. So, like I said, I won a trip to San Francisco. So, you all gotta enter that raffle. I'm gonna enter it right now. Okay, well, thanks so much for having me. Y'all can stick around for another hour and have some pizza and.